Karibu Ibrah Network Lab. Hii ni kozi kamili ya Cisco Certified Network Associate. Kupitia kozi hii utajifunza jinsi gani na namna network inavyofanya kazi.
Okay, for those who are not familiar with the Wireshark is a network analyzer. It is just like a CCTV camera that is used to capture and monitor each and everything that is going on over the network. And this tool is more powerful, and it is mostly used by network engineer for troubleshooting, and you can use it for learning by integrated with the different network simulation tools such as GNA3 or even G. So you can use it for learning, and you can be able to capturing and learning different packets and traffic over the internet. Anyway, let's get started. And I also put the link in the description of the Wireshark so you can use it to download for yourself. Okay, so this is a user interface of the Wireshark. So once you install it, the Wireshark on your desktop, this is how it is going to look like. Now, for this video, we're going to focus with only a few things from this Wireshark capturing, because as you can see, it has got a lot of options that we can go through. But for this video, we're going to cover only a few things. And once you see here, there is different here at the top and the bottom down, there is different network adapters. And for you to determine to know which interface is active and which interface is going to be captured by Wireshark, you see here there is couple of the there is a couple of the network adapter. But this at the top here, as you can see, there is wavering. The one which is wavering, this represents that the Wireshark is used to capturing the different traffic and packets from that network adapter. Now for this scope, as you can see, my Wireshark is used to capture the traffic and packet from my network adapter, from my wireless, from my VMs, and also from the loopback interface. So which means my Wireshark now it is used to capturing different traffic and packet which are communicating from this network adapter. Anyway, let's get started. But one thing also I can share with you here, you can minimize this traffic. Maybe if you don't want to capturing from this VM, you can come here at the top, then capturing option and manage interface here, and you can unselect the one which is not the one which you don't want to capture. So for example, if we unselect this one, and once we press OK, we close. Now this interface they're going to be removed here. As you can see now, the one which Wireshark is used to capturing is only from my Wi-Fi. So you can use it to disable or enable them from that option there. Anyway, let's get started from this one here. So I select from my Wi-Fi network adapter, and indeed, after you double click it and you select that, once it is open, it is going to show you like this. So my Wireshark now, it is capturing each and everything that is going on from my network through my network adapter, which is a Wi-Fi. As you can see here, there is a different protocol and the packets that are being captured by my Wireshark. Anyway, as I said, in this video, we are going to focus with only a few things, as we discussed in the previous video for IP version 4 header. I need you to show you in my Wireshark to show you how IP version 4 header it is working in the real world. Since we had just a discussion on the lecture video, now I need you to show you in the real world how does this work. So what you're supposed to do is to select any row which contain any protocol. So you can select for the DNS, can be TCP or TLS and so on. But for this scope, I have selected for the TCP. But you can choose anyone. After you have selected the TCP, once you come to view here at the bottom, there is different option that has appeared here. Let's view them here. As you can see here, there is a frame, there is Ethernet 2, and the Internet Protocol version 4, and the last field is the Transmission Control Protocol. Now, in this lecture video, we're just going to cover the few things, which is we are going to view about the IP version 4 header. But before I switch to IP version 4 header, I just wanted you to share with you also about the Ethernet header that we discussed in the previous lecture video. We had a discussion about the Ethernet header, and we see different fields that are contained in the Ethernet header. We see the destination, the source MAC address, the length of type, we see the payload, and finally we see the frame check sequence. Anyway, do you remember these fields in the Ethernet header? the destination MAC address, the source, the type, and so on. And this field is used to determine, to tell us what actual data is going to be contained in the payload. Do you remember it? This bit, the represent what? This bit is used to present that the payload is going to contain the type of data which is IP version 4. Anyway, take your time, go and pursue about this if you don't know. Okay, let me switch to Internet Protocol version 4 header. And what you see here is what we discussed in the lecture video. Now, the first field here is the version. This field is used to tell us which type of address was used in IP header. And for this scope now, it is used to tell us the IP version 4 was used from this IP header, which is represented by this binary bit, which was 0100. The next field here is IHL, which stands for Internet Header Length. This field is used to tell us the length of IP header. And once you remember, this field is determined by 4 bytes incremental. Now, as I said also before, the minimum value of this field is 5, and the maximum value is 15. So for us to determine the length of this IP version 4 header, we're supposed to take the minimum value of this IHL field, then we're supposed to times by 4 incremental bytes. That's going to determine the length of this header. Anyway, the next field here is the differentiated service field code point. This is used by QoS, the quality of service, which it is used to prioritize the very sensitive data. And also the next field, it was ECN, which is stand for explicit congestion notification. And once you remember, this field is used to notify between both two ends, node to node. If there is any network congestion, that packet should not be dropped. And the next field here is the total length. Now this field is contain the encapsulated layer 3 header and the layer 4 segment. This is where the actual data is going to be contained in IP version 4 header. Now the next field here is identification field. Now in this identification field, once you remember, for it to happen in IP version 4 header, for example, the router has received the packet which has exceeded the maximum MTU size. Now that packet is supposed to be fragmented, because for example, if the router is used a standard Ethernet MTU, it could not be able to fragment, it could not be able to receive and forward that packet if it is not being spliced into fragments. So now this field is going to fragment that packet if it has received the MTU size. Now the next field here, the flags. Do you remember the flags? There was 3 bits. Now these bits, they're used to tell the router if the packet should be fragmented or not. Now if it was set to 0, this means it's being reserved, it is going to be set forever. And if it was used by bit 1, this means it's DF, that stands for don't fragment. And this DF, it has got 2 values, and be 0 or 1. So those values are going to help a router to know if that packet should be fragmented or not. 0 represents should be fragmented, and 1 represents that should not be fragmented, that is don't fragment. That's a value if the router, if the flag was set to DF. So if it could be 0 in the DF, it means maybe fragmented. If it could be 1, this means don't fragment. The packet should not be fragmented. Now, the another bit, it was bit 2, which is MF, which stands for more fragments. And also it has got 2 values, 0 and 1. 0 means there is no any other fragment which is coming. It is finished. And if it is set to 1, which means telling the receiver, keep waiting, there is more fragments which are coming. Anyway, that is all about flags. Now the next field here is about the fragment offset. The fragment offset, these are going to help the receiver to know that the origin of each fragment. So for example, if the fragment was arriving out of order, now the receiver, they're going to use this fragment offset to know that the origin of each fragment according to its position. Now the next field here is the time to leave a field, TTL. You remember the TTL? The default value of TTL, it is 64. So this TTL, it is going to prevent the infinite loops over the internet. It is going to be decreased by 1 whenever it is received by the router. So whenever the packet is sent for the first time, it's going to arrive to the router. By default, the router is supposed to decrease the TTL value by 1. Anyway, the next field here is the protocol. This protocol field, it is used to tell us which type of protocol was used from this IP version 4 header. So for this scope, it tells us the TCP, this was used by our IP version 4 header. And do you remember these values that are used to expand whenever you see 6? This represent the value, I mean, this represent it was used the TCP. If you see 89, that represent it was used the OSPF. If you don't remember about this, please take your time, go and pursue in the previous video. Now, the next field here is the header checksum. The header checksum, it is used to check if there is any error that was happened during the transmission of this packet from the source to the destination. And this it is going to be used by the receiver. It's going to use the same calculation that was done by the sender. So it's going to look and cross-check and matching the same calculation. If it matches, then the packet is going to be de-encapsulated. If the values are not matched, the receiver is going to discard that frame. That packet. Then the next field here is the source and the destination IP address. This used to tell us the source IP address was what and the destination IP address was what. So here is the source IP address and the destination IP address, the targeted device. Then, as you remember, the last field it was option. I used to say that for the option to occur in IP version 4 header, the IHL field is supposed to be greater than 1. Now let me show you that. Okay, I have entered this command in my Windows PC. I have pinged my default gateway, which is address of my router now. Then at the end of this command, I have increased the payload size, which is 4000 bytes. Now, once I come into view here in my Wireshark, in IP version 4 header, in the section of the flag, at the beginning, it was don't fragment. It was here, it was set to 1, which is don't fragment. But after I have entered that command and I have increased the payload size, it has shifted to more fragment, which is MF. Now, do you remember the values of MF, which was 0 and 1? If it is 0, that's telling the receiver that there is no any fragment which is coming. But if it is set to 1, this will represent that there is no fragment which are coming. So he's supposed to stay cool and waiting.
Okay, after we have seen different fields in IP version 4 header, and we have seen the identification field, which has got the function kwamba endapo itapo receive any packet which has exceed the MTU size, which is 1500 bytes, so hiyo packet automatically inakwenda kuwa fragmented. And the next field baada ya identification flag is the flag, na flag hiyo it is 3 bits long, ambapo ina bits 3. Bit number 0 ina represent kwamba hizo packets zinakuwa reserved forever and they're going to be used for the future. Lakini pia ikiwa imeset to bit number 1, basi na represent hiyo ni DF, ambayo stand for don't fragment. Don't fragment ina value mbili, either 0 or 1. So kwa mfano ikiwa set to don't fragment, lakini ikiwa ina value number 0, manake inasaidia kumwambia router kwamba hii packet may be fragmented. This packet may be fragmented. Lakini pia ikiwa imeset to don't fragment lakini ina value number 1, so this represent kwamba this router should not fragment those packet. So inatakiwa iache kama zilivyo. Lakini pia ikiwa set to bit ambayo ni more fragment, which is bit 2, hii ina represent kwamba inamsaidia receiver kuweza kujua, kwa sababu yenyewe ina value mbili, 0 and 1. So 0 maana yake inamwambia receiver kwamba there is no any other fragment which are coming. So anaweza akatumia kuweza kureassemble na kuweza kujua the clear picture of how the packet which was sent from the host. Lakini pia ikiwa imeset to MF lakini value it is 1, inamsaidia receiver kumwambia kwamba he is supposed to stay cool because there is more fragment which are coming. So 1 manake there is more fragment which are coming, lakini ikiwa set katika MF which is more fragment, lakini ikiwa 0 ina represent kwamba there is no any other fragment which are coming. So receiver anatakiwa aendelee ku reassemble those packet ambazo amesha receive kuweza kupata the clear picture ama the full image ya hiyo packet ilivyotumwa kutoka from the source ambapo ndio sender. Then baada hapo tukaona field inofuata ni hizo fragment offset. So hizi zinamsaidia receiver kuweza kujua the origin of each fragment as it was sent from the source. So kwa mfano these packet, those fragments zime receive in out of order. kama ambavyo zilivyotumwa kutoka kwa the sender. So fragment offset inamsaidia receiver kuweza kutumia zile fragment kujua kwamba hii fragment inatakiwa ikae hapa, hii fragment hii inatakiwa ikae hapa, in spite of zime arrive in out of order. Now let us shift and see this option field kama nilivyosema hapo before. Nilisema kwamba option field in IP version 4 header it is rarely found kwa sababu inatokea kwa mara chache sana. Kwa nini inatokea mara chache sana? Kwa sababu if the IHL field hii hapa internet header length ikiwa greater than the minimum value ya IHL field ambayo ni 5, basi the option field katika IP version 4 lazima iokaa. So kwa mfano hapa, this is the screenshot which show you that the IHL field was exceed the minimum value which was 6. And we know the minimum value katika IHL field it is 5 by the way. Now, as I said before, if the IHL field is greater than 5 than the minimum value, now automatically the option field is going to be available from that IP version 4 header. And indeed, as you can see here, now we have seen the option field, it is 4 bytes. So manake nini? Manake kwamba whenever it is exceed, ikiwa 6, ikiwa 7, ikiwa 8, hata ikiwa ile maximum IHL file ambayo ni 15. So this means kwamba the option field is going to be available. So keep it on mind that if the IHL field is greater than the minimum value which is 5, now the option field is going to be available from that IP version 4 header. Okay, I'm hopeful now this video was helpful for you since we have covered different parts of IP version 4 header in the lecture video, and finally we have seen it in the real world. How does IP version 4 header looks like and how does it work? And please don't forget to support me by subscribing my channel, drop the comment, and please don't forget to share this video to your friend. Thank you.